Hello everyone, welcome to the channel of Algocamp. So now on this particular channel, we are actually releasing a series on data structures and algorithms where we are going to talk about some of the most important data structures and algorithmic topics which are extremely important for your upcoming software engineering interviews. Apart from that, these are some of the I would say topics that are very helpful in your day-to-day engineering job as well. We have already released a couple of series around searching, right? And we got a really good response on that. And from here, we are going to put really some awesome content around DSA. In most of these lectures, we will try to ensure that we focus on the intuition building aspect of the things, that how you are able to think about something, what are some of the things that people actually neglect but are going to clear some of the really important fundamentals. We are going to see coding implementation, but trust me, my focus is not going to be on the language delivery aspect of the things, that okay, you have to code this in C++ or Java. A lot of problems we have coded in multiple languages. Maybe some of the problems will be in C++, some will be only in JavaScript. I believe if you are somebody who is preparing for an interview, language in 2025 should not be a constraint, because most of the people can actually use ChatGPT to do language conversions. So my motive here is to make sure that you understand the concept in depth. You actually see how exactly somebody might have thought about the problem when they were carving out the problem, what can be some initial thought process, how you can actually drive yourself towards the solution. I believe these are going to be some really important videos that will be really helpful for your upcoming career. So do let us know what is your feedback. We are going to release a lot of more topics. Do let us know what all topics you want to have first, right? And the feedback is going to be important. Also, in case you are actually thinking to level up, you want to learn things with respect to low-level design, high-level design, overall system design for interviews, or you are somebody who wants to do project development in Spring Boot, you want to learn advanced Spring Boot concepts, or let's say advanced Node.js concepts, then we have a lot of courses, live courses running on algocamp.io. So you can check out the website courses.algocamp.io/learn, and there are a lot of courses that are actually listed. A lot of great discounts are actually going on all the courses as well. Do check them out. For each and every single course, we are going to add you to a dedicated Discord community where you can get your doubts resolved as well. All of the courses, we have made sure that we talk about things from the very beginner to the very advanced level that is going to help you level up in your career as a software engineer. So that being said, let's start the video without any further delay. So this is a new problem in front of us. The problem says that given a number n, you need to calculate the sum of digits of n recursively, right? So you will be given some number n, for example 1 2 3 4. You need to somehow go to each digit and sum up all the digits. So 4 plus 3 plus 2 plus 1 sums up to 10. 4 plus 3 7, 8 9 plus 1 10 sums up to 10. So you need to calculate sum of the digits, right? One number can be formed by multiple digits, right? It's a collection of digits. So all you have to do is separately add up all the digits and return the sum. The only catch here is you have to do this recursively, right? Okay. Now before I go into a recursive functionality, how we could have solved it using just normal loops? If I wanted to solve it just using normal for loops, while loops, whatever it is, then it was a very straightforward thing, because there are a few questions that you might be getting in your mind. How to go to every digit, right? This might be the biggest question, that how actually I go to every digit one by one, right? How do I go to every digit one by one? So if you want to go to every digit, like first you want to go to, let's say 1 2 then 3 then 4, or in the reverse order, that somehow, let's say if I get 4 then 3 then 2 then 1, anything will work for us, right? We somehow need to go to every digit. Now technically instead of going to every digit, what we can do here is that, so before we start this particular video, I wanted to actually talk about a very small thing. So this video is going to actually help you understand a real system design interview scenario. We are going to try to mimic a 45 to 60 minute kind of like a round where we are going to solve a problem very similar to how you will solve a similar system design problem in this short time frame. Now, of course, when you work as a software engineer in a company, you have relatively larger amount of time and you can do a lot of more deep dives in even very small level features. But in an interview, the temperament is different, the approach is different, and a similar scenario is actually explained in this particular video. So do consume the content based on that. Also, if you want to see more deep dives and want to understand these topics in a much more deeper level concepts, then do check out the link in the description section below for our System Design 2.0 cohort, where we have talked about a lot more concepts in a lot more detail, which will make you definitely a better software engineer. So let's just start the video. We can try to extract every digit one by one, right? Instead of going or iterating over every digit, we can extract every digit. How can we extract every digit? Let's see. So if let's say you have been given a number 1, 2, 3, 4, and if I ask you, how can we easily fetch the last digit? How can I just easily fetch the last digit? Now, for any number, if I divide that number with 10 and get the remainder, then let's see what happens. So if you divide 1, 2, 3, 4 with 10, you will get 123 into 10 is 1230, and this is your remainder, right? This is remainder and your last digit also. So whenever you have a number, if you can just calculate the remainder that we will get by a division of 10, you will be able to extract the digit. So can I say, if I will do n mod 10, I will get the last digit, right? So we know how to extract the last digit. Okay, we don't know how to extract the other digits because other digits can be tricky. Now, because we know how to extract the last digit, how about after extracting the last digit, can we now remove the last digit? Right? Like somehow, if we can reduce 1, 2, 3, 4 to 1, 2, 3, that is removing the last digit, then I can repeat the process, right? Currently, what did I do? From 1, 2, 3, 4, I extracted 4. Very good. Now I want to extract 3. So before we extract 3, I am saying, how about you reduce the number to 123 and repeat the same process of remainder with 10. You'll be able to extract 3. Then repeat the same process that you somehow remove 3, get 12 and extract the remainder with 10 and so on. So every time I'm trying to fetch the last digit and I want to then remove the last digit so that I get access to the second last digit as the last digit, because in 123, our 3 becomes the last digit. Now, how can we remove the last digit? Now, I can say that if you see the quotient in this division, if you see the quotient of division by 10, this quotient is not having the last digit. If you divide 10 with 123, then 10 into 12 is 120, remainder is 3. You get the remainder here, and you can see in the quotient you don't have the last digit. So if you just do n is equals to n by 10, then we can remove the last digit, right? Using this process very easily with for loops, we will be able to extract everything, or while loops, we will be able to extract everything. We'll be able to extract every digit one by one and then remove the digit. So if I just want to write a quick while loop based solution, I'll say while n is greater than 0, let's do int sum. We can say sum plus is equals to n mod 10, that is whatever is the last digit added to the sum, add last digit to sum, right? And then we can do n is equals to n by 10, remove the last digit, and that's it. Return sum. That's it. Right. We could have just simply done this much part. Right. Okay. Now we have to achieve the same thing recursively. We have to achieve the same thing recursively. Right. Let's see how we can move forward with recursion. In recursion, we need a function, right? So we need some function f that can calculate sum of digits of n, right? So of course it will be taking a number n as the parameter, and it will be somehow calculating the sum of digits of n. Okay. So for example, we have been given 1, 2, 3, 4, right? F will somehow calculate the sum of 1, 2, 3, 4, digits of 1, 2, 3, 4. Okay. Now how f can do this? How f can do this? Let's try to figure out. Now again, I don't know how f can figure out the sum of the digits, right? I don't know how to implement f. But let me explore something very carefully. Can I say that if I want to calculate sum of 1, 2, 3, 4, this is a bigger problem, right? This is a bigger problem in hand to calculate sum of all of the digits. If somehow I can get the sum of 123, if I can get this, right? That is, if somehow somebody can give me the sum of 123, not 1, 2, 3, 4, just 123. If somehow someone can give me the sum of 123, I can add 4 to it myself, right? So what I'm trying to say is that if we have to calculate the sum of n and somebody can give you the sum of the smaller part of n, then you can just add the last digit, right? So what you can say is that if somehow we assume, let's assume the function f works correctly for n by 10, right? That is, if you have 1, 2, 3, 4, that is f of 1, 2, 3, 4, we assume that the function works correctly for 1, 2, 3, 4 by 10. What is 1, 2, 3, 4 by 10? 1, 2, 3, 4 by 10 is 123. So we assume that the function works correctly for 123. So here if I say that the function f works correctly for n by 10, that means the function f calculates the sum of the digits except the last digit correctly, right? So we can say if f works correctly for n by 10, this is assumption. So we will be able to get the sum of 123, right? Now, if you have already calculated the sum of 123, all we have to do is inside our self work, we just need to add n mod 10. Self work to add the last digit. That's it. That's it, right? The same thing we were doing in looping also. We were extracting the last digit and going for the remaining part. Here, what we are saying, just go and extract the sum of the remaining part. In that sum, I'll just add the last digit, and that is it. And that is it. What will be the base case? The base case will be if the number becomes 0, if the number in the input is 0, then the sum of the digits is also 0. Can I say that? As simple as that. If the number in the input is 0, the sum of the digits will also be 0. Simple base case. The smallest value of n, or the most trivial value of n for which we know the answer is 0, because the sum is going to be 0. And then to implement things recursively, what did I say? I said that we are going to assume that we will get the sum of 123 correctly. Somehow, somewhat, we will get the sum of 123 correctly. And then we will add 4 to it. We will add 4 to it. So how things are going? You ask for the sum of 1, 2, 3, 4. I will delegate this task to A. That, hey A, please calculate the sum of 123 for me. Whatever you will return, I will add 4 to it. A will say, okay. A will delegate the task to B that, hey B, please give me the sum of 12. Whatever you will give, I will add 3 to it. B delegates the task to C that, hey C, please give me the sum of 1. I will add 2 to it. And C delegates the task to D that, hey D, please give me the sum of 0 and I will add 1 to it. Now D is smart. D just realized that sum of 0 is what? 0. D is immediately going to return you 0. Now on C, I have the sum of 0. To that, I will just add my last digit. What is your last digit? 1 mod 10 is 1. So summing up your last digit with 0 is 1. So you are going to return 1 from here. So sum up till 1 is 1. Now you are at 12. You will say that we have extracted out the sum of 1. That is 1. I will add my last digit. So 12 mod 10 is equals to 2. So I will add 2 to it. So 2 plus 1 is 3. Right? Can I say 2 plus 1 is going to be 3? And once you have calculated 2 plus 1, that is 3, then you can return this 3 above. You can return this 3 above. Now you have the sum of 12. The sum of 12 is 3. You have it. Once you have the sum of 12, you can just add your last digit. What is your last digit here? 123 mod 10 is 3. So 3 plus 3 is what? 6. And you return 6. And once you have calculated the sum of 123, now this was us, right? F of 123 was us. We were expecting the sum of 123. Sum of 123 is 6. I can just add my last digit. 1, 2, 3, 4 mod 10 is 4. I can just add my last digit to it. And this will become 10. 6 plus 4 is 10. That's it. That's it, right? This is how we can extract the sum of digits. And even in the coding implementation, you will see, I will write the same functionality as it is, no sugarcoating at all. And you will be able to extract out some of the digits, right? So let's quickly hop on to the coding implementation and see what I have to offer. So I'll say sum of digits, recursive. Okay. I'll write a function f, int f. Now why int f? Because I want to return a sum. So that's an integer value that we can expect. It will take a value n. So see, f of n we wanted to write. F of n we have here. Right, f of n we have here. Now first of all, base case. We say that if n is 0, the sum is 0. If n is 0, digit sum is 0 only. That's it. That's our base case, right? If n is 0, return 0. Otherwise, we can say return f of n by 10 plus n mod 10. That is, bring me sum of n by 10. I will add my last digit to it. That's it. That's it, right? I can call f 1, 2, 3, 4 here. If you run it, see, we are getting 10. That's correct. If we go for 1, 2, 3, 4, 5, we are getting 15. Makes sense? And just by using this simple two-liner code that we can of course reduce to one line also if you use ternary operator, we have calculated sum of digits of a number very gracefully. I hope this point makes sense to everyone. Now let's have a quick dry run. Okay. So I'll draw the call stack here. And from my main function, I'm going to call for f of 1, 2, 3, 4. Okay. Let's see. So the first function that will be called, of course, is going to be main. From main, I'm going to call for f of 1, 2, 3, 4. Okay. So the first function call is for f of 1, 2, 3, 4. We want to extract out the sum of digits of 1, 2, 3, 4. Okay. So can I say here the value of n is 1, 2, 3, 4. Okay. Value of n is 1, 2, 3, 4. You will check. Is n equals to 0? Is n equals to 0? No. So you are on line number 4. On line number 4, you expect a recursive sum, right? F of n by 10. You say that I want this function was expecting to calculate sum of 1, 2, 3, 4. If you can go and calculate 1, 2, 3, 4 by 10. What is 1, 2, 3, 4 by 10? 1, 2, 3, 4 by 10 is what? You will get 123 because 1, 2, 3, 4 by 10, if you get the quotient is 123, right? So you are going to make a function call from here. So I'll wait for line number 4. This stack frame is going to wait on line number 4. And we are going to make a function call for f of 123, right? Okay. Now we are at f of 123. Now the value of n is 123 here. These two function calls are waiting. We are at here. N is 123. Now you check. Is n equals to 0? Is n equals to 0? No. So this if check won't be executing. We are again on line number 4. On line number 4, we say that f of n by 10. So there is a recursive function calls. Post that we are going to do something, right? So f of n by 10. Now what is n? N is 123. What is 123 by 10? 12. You will just eliminate the last digit. So you are saying if you want to calculate the sum of 123, just give me the sum of 12. I'll add 3 to it. So now let's go and calculate the sum of 12. F of 12. Here n is 12. You check. Is n equals to 0? No. Again, you are at line number 4. You are going to make a function call. Post that you are going to do something. So a function call. And function call to what? 12 by 10. What is 12 by 10? 1. So you're going to make a function call to f of 1. Here n is 1. Okay. You're going to check. Is n equals to 0? No. We'll make a function call. And function call to 1 by 10. What is 1 by 10? 1 by 10 is 0. We're going to make a function call to f of 0 from line number 4. Now here, what is the value of n? N is 0. We check. Is n equals to 0? Yes. You return a 0. So from here, we are going to return a 0 to this function call, and that's it. Now we are back on f of 1 and we got the sum of f of 0. So what we have to do? We are back on line number 4. On line number 4, we got this as 0 plus n mod 10. What is 1 mod 10? 1 mod 10 is 1. Right? So this will be 0 plus 1. What is 0 plus 1? 0 plus 1 is 1. So you are going to return 0 plus 1, that is 1. So from here, I'm going to return a 1. And that's it, because we have returned. This stack frame is going to get removed. Okay. We are on this stack frame. F of 12. On line number 4, we left f of 12. On line number 4, we left f of 12 for f of 1. F of 1 has given us 1 plus. What is 12 mod 10? 12 mod 10 is 2. So this value will be 2. Now we have to return 1 plus 2. So 1 plus 2 is 3. I'm going to return 3 here. And this function call is also done. Right? Then f of 123. For calculating f of 123, we were expecting to calculate f of 12. That we have already got 3. Here we got 3 plus. We want to do 123 mod 10. What is 123 mod 10? Last digit. That is 3. So this is going to be 3. So all you have to do is return 3 plus 3. 3 plus 3 is 6. We will return a 6 here. And this function call is done. Okay. Now we are at this function call. We are at this function call, which was our original call. F of 123, 1, 2, 3, 4. Now 1, 2, 3, 4 was expecting you to go and calculate 1, 2, 3, 4 by 10. What is 1, 2, 3, 4 by 10? 123. So it was expecting you to calculate the sum of 123. What is the sum of 123 that you have calculated? 6. So you went and calculated the sum of 123. This is 6. Now n mod 10. What is 1, 2, 3, 4 mod 10? Can I say it is 4, last digit? So now you have to return 6 plus 4. That is sum of all of the digits of 1, 2, 3, 4. That is 10. And this function call is also done. That's it. That's it. You are back inside main and you have the sum as 10. This is the simple dry run for the recursive implementation of sum of digits. What is the time complexity of this solution? Now you can see, I have told you inside basic recursive function, what is the time complexity? Number of times the function is called multiplied by number of operations in each function call. If you see 1, 2, 3, 4 was calling 123, it was calling 12, it was calling 1, it was calling 0. So if there are d digits, number of digits, can I say there are d plus 1 function calls, which is approximately d, right? And in each function call, you have a if check, which is constant, remainder constant, sum constant, triggering a function constant. So with d function calls, you have constant operations everywhere. So that time complexity is order of d, which is number of digits. And even if you see the space complexity, this was 1, 2, 3, 4, you call for 1, 2, 3, you call for 12, you call for 1, you call for 0. So at one point of time, you were having d plus 1 stack frames that were consuming the space. So can I say space complexity is also order of d? D plus 1, we'll just reduce 1 because 1 is a lower degree term. And that's it. That's the time and space complexity analysis for sum of digits using recursion.